Well, since we've multiplied and simplified radicals, now it's time to divide and simplify radicals. Again, the idea is if they have the same radical, whether they're both square roots or cube roots, and you have the same radical in the numerator and denominator, then we are allowed to divide and simplify first, and then take the root and see then if we can simplify even more. So when you look at the first one, everything's under a square root. So first I'm going to divide my numbers. 18 divided by 2 is 9. And then when I divide my x to the fifth over x to the third, remember that is an exponent rule. We're going to subtract our exponents when I divide. So 5 minus 3, I get x squared. And then we're going to take the square root of that. What I have is I actually have everything perfect. I'm just going to kind of put a big box around everything. I'm not going to have any leftovers here because the square root of 9 is just 3 and the square root of x squared is just x. So everything under the radical after we divided was already a perfect square. Next one, 162 divided by 3. You may need to grab a calculator. Check out 162 divided by 3. You get 54. And then when you subtract exponents with the y's, you get y to the third. So 54 is not a perfect cube. However, 27 divides into it, and that is a perfect cube. Y cubed is also a perfect cube because the power and the root divide evenly. So I'm not going to have a lot left under the radical. So the cube root of 27 is 3. The cube root of y to the third is y. And the only thing left under the cube root is a number 2. Last one on this slide, we're going to divide 50 divided by 2 and get 25. And then x to the 6th divided by x to the 4th is just going to be x squared. Everything here is perfect. Square root of 25 is 5, and the square root of x squared is just x. So nothing left under the radical because everything was perfect. Here's a few that are a little bit bigger, but pretty similar. So 48 divided by 3 is 16. X to the third divided by x is x squared. And then you'll notice the y squared, the only place we have a y squared is in the bottom. So we still have that y squared in the bottom. However, when we go to simplify, one thing you'll notice is everything again is a perfect square. Take the square root of the top, we get 4. Take the square root of x squared, we get x. And take the square root of y squared, we get y. And we no longer have a radical because everything left underneath was perfect. Next one, 250 divided by 2 is 125. X to the 7th divided by x to the 2nd is x to the 5th. Y to the 3rd divided by y is y squared. And I'm taking the cube root of that. 125 is a perfect cube. I do not need to break it down. X to the 5th is not. I'm going to have to break it down into x to the 3rd and x squared. That's the perfect one. And y squared, the power is actually too small. It's not divisible by 3 because it's not even equal to 3. So that's going to be left over along with the x squared. So the cube root of 125 is 5. The cube root of x cubed is x. I'm taking the root of all the stuff I put in boxes. And then I'm left with an x squared and a y squared underneath my cube root. And then finally, the last one, 56 divided by 7 is 8. X to the 5th divided by x is x to the 4th. Y to the 5th divided by y is y to the 4th. And we are square rooting the whole result when I divide. 8 is not a perfect square, but it can be broken down into 4 times 2. X to the 4th and y to the 4th are both perfect because they are both divisible by root 2. 4 divided by 2 works out perfectly. So we end up with the square root of 4, which is 2. And then x squared when I take the square root of x to the 4th, and then y squared. And the only thing that was left over under your square root is just the number 2. So that is how we divide first by dividing your coefficients and subtracting your exponents on your variables, and then simplify the result using either perfect squares or perfect cubes depending on the radical.